So in this lesson, we are going to look at an example from our handout on Euler's method. And we're going to implement Euler's method using a spreadsheet. So the equation that we're interested in is this equation, y prime equals negative 2y plus 5t. We've already filled out a table by hand doing about 5 steps of Euler's method. And now I'd like to show you how to automate that process using a spreadsheet. So Euler's method says that the next step, y of k plus 1, is the previous step, y of k, plus the slope, f of t of k, y of k, times dt. And so what I've done is I've set up some columns. K is going to be the number of steps, so steps 0 through 5. I'm going to set up a column just for dt. And this first time, we're going to use 5 steps. And we want to solve all the way till t equals 2. And so our delta t is, for solving for till t equals 2, it's going to be 2 minus 0 divided by our number of steps, which in this case is 5. So that gives me a delta t of 0.4. So we're going to have a column that just has delta t in it. Since it already has a 0.4, you can essentially, you can copy and paste this delta t into the rest of the column. So either use the copy function. So it might be Control C or Command C, depending on what computer you're on. And then you can highlight the cells, all of the cells, and then paste. That's one way in which you can copy delta t. Or if you click on the very right bottom corner of the cell, that creates a plus sign instead of your mouse's normal arrows, this black plus sign. And then you click there and you can just drag it down, and that will give you 0.4 everywhere. Okay, so the next column is going to be the t values. Okay, and so I filled in the first t value. We're going to start at t equals 0, but I want to have all of the other t values in there. So what I'm going to do is I'm going to say that the next time is equal to the previous time, and I'm not going to press 0. I'm going to click on the cell. The cell there is C5. Okay, but I'm going to click on it so it puts it into a formula. Don't put 0, but actually click on the cell. And then I'm going to add to it the delta t. So I'm going to pick the delta t that's just to the left of this. So I'm going to click on delta t there, which is in this case, the cell B6. So don't put 0.4, but actually click on the cell. And the reason that you're going to do this is that Excel is going to use that formula, essentially saying the next time is always the previous time, which is located in the cell above this cell, plus delta t, which is located in the cell to the right of this cell. And then I'm going to hit enter. And then I'm going to also either copy and paste or drag this down. And you'll see that that gives me the time frame. The time is going to be start at 0, then go to 0.4, 0.8, 1.2, 1.6, and then 2. Okay, so that gives me the time column. Okay, you can see if I come down here, notice that, for example, this time is equal to the cell above it plus delta t, which is to the left. If I go to the next cell, you can see it's equal to the time above it plus the cell to the left of it. The next cell is always the time above it plus the cell to the left of it. So you can kind of see how Excel works there. I'm going to have a column that's going to represent the y's. My initial y is 5. I kind of have it keyed up here so that I can, in this row, I can just specify what y of 0 is and what dt is, because a lot of the formulas I'm going to use are the same. And then I wrote this column, I wrote mk, because a lot of times when we have the equation of a line, we say y equals mx plus b. And so I decided m would represent the slope. Okay, so that's why I wrote m sub k there. That's the slope. And so what is the slope? The slope is going to equal essentially the right-hand side of the equation. So actually, I'm going to write this out one more time, this Euler's formula, but instead instead of writing it in terms of f of tk yk, I'm going to write it out in terms of what f of tk yk is. So here, f of tk yk is the right-hand side of the differential equation. Okay, so the right-hand side is -2 times y of k plus 5 times t of k. So you can see that my right-hand side is -2y plus 5 times t. That is what I'm going to put in for the slope. So I'm going to say the slope is equal to -2 times, then I'm going to click on the y cell. Okay, so it's very important. We're not going to write 5. I'm going to click on the y cell so that it'll use that formula. So -2y plus 5 times, and then I'm going to click on the t cell. Okay, so that way it refers to y, which is in the column just to the left of the slope, and then it refers to t, which is in the column 2 to the left of the slope. So that's the formula for slope. So it's -2 times y plus 5 times t. And then lastly, I'm going to say that the thing that I want to add to the next y value is the slope times delta t. So the slope, I'm going to click on that slope, which is just to the left of that column, times, and then I'm going to click on the delta t, which is just to the left of that, or it was a few columns to the left of that column. So I'm going to add slope times delta t. So -10 times 0.4 is going to give me a -4 there. So that is how I'm going to fill in those columns of Euler's method. The very last step is that I have to take y of k, and then I have to add to it slope times delta t. So I'm going to say that this is equal to y, the previous y value, plus slope times delta t. Notice again, I'm clicking on the y, which is just above, to give me the cell D5, and then I'm clicking on the slope that's associated with that step. That's in cell F5. So that will give me my next y value. Okay, so I'm going to take 5, subtract 4, and that's going to give me 1. Now, what's nice is that once I've done this many steps, I don't need to do any more entering of formulas, because the next slope, if I copy this slope, the next slope is going to be just pasting the same formula in. So I used my Command C or Control C to copy, and then I just paste it in the next slope. So the next slope happens to be 0. Okay, so I'm going to copy my slope times dt, and then I'm going to paste it in. Of course, if you take the slope of 0 times delta t, and you're going to get 0 again. Okay, so I can just copy the previous cell and then paste it, copy the previous cell and paste it, because I now put those formulas in. And now in this row, all these formulas that I've put in fact, so the formula for the new t, the formula for the new y, the formula for the slope, the formula for slope times dt, all of these are now going to be the same formula throughout. And so if I want to just finish Euler's method, I can either copy and paste, or I can make this plus sign in the lower right corner, of this highlighted row there. And then I can just drag it down, and that will give me Euler's method. Okay, and so here we see that that our estimate of y of 2, so at t equals 2, we estimate that y is 3.75. I'm going to actually add another decimal place here just to so that we can compare to our chart. In fact, it's 3.752. Hopefully you'll see that I've kind of started a graph for us. In the graph, the purple line is actually the exact solution. This is a differential equation that we're not going to necessarily learn how to solve, or at least not solve efficiently, but this is a differential equation that can be solved. So I went ahead and put the exact solution into this graph. That's the purple curve. And then the red dots represent my approximate solution. And so this is what Euler's method looks like when I use 5 steps. And while it's not a very good approximation at the beginning, as you can see, it goes way down at the beginning. In fact, it is a pretty decent approximation. It kind of levels out. It's a pretty decent approximation when I get to time t equals 2. Now, before I go on and do a couple more of these approximations, are there any questions about any of the steps that I did for Euler's method? So I'll pause for a moment.
Can you repeat how you got m sub k?
Sure. So looking at m sub k, so I'm going to just go ahead and do it one more time. I'm going to say, so I always put an equal sign. That's so I can start a formula. Okay. The slope is supposed to be -2 times y. So -2 times, and then I click on the column for y. And then I'm going to do, because it's -2y, and then I do plus, and then 5, and then I'm going to click on the column for t. And so that gives me the formula -2y plus 5t. Okay, so and then I can once I have that formula, I can copy and paste it all the way down. That gives me the formula. Are there any more questions?
I have one of my DTs is at 0.4 is at 5 instead of 1 where yours is. My graph looks the same. I don't know. Yeah, like so the first one that's on like your y value of 1, mine is like at 5, and I'm not sure if what might cause that.
Are you talking? You have just an issue with the graph, or you have an issue with?
Yeah, the graph, like the formulas, everything else looks the same. But
okay, well, after this is done, I'll help you figure out the graph. But okay. Is your table correct?
Yeah.
Okay. Well, as long as your table is correct for now, I can kind of work with the graph.
Okay.
Okay. Does anyone else have a question? Okay, now I've set up this work. Now I would like things to I would like to repeat this work and not have to type all these things in again. So this formula for slope, I put it in here. Now I'm going to let delta t be 0.1. So I can just copy this formula for slope in and paste it right there. And the initial slope doesn't change. The only thing that changes is slope times delta t. I can copy that cell and just paste it here. And slope times dt should be -1 because it's -10 times a delta t of 0.1. In fact, I could copy this whole second row and paste it right here. Nope, that didn't work. Sorry, guys. Okay. The thing I need to do is I need to copy and paste the delta t's first. Okay. Then I can copy the rest of the second row because of the way I set it up. So I can copy the rest of it, and then that gives me the new t value, which in this case is 0.1 because I've started at 0 and added to 0.1. It gives me the new y value, which because I'm subtracting slope times or adding slope times delta t to my previous y, so I'm adding -1 to 5, so that's going to give me a 4. And then it's going to give me the new slope and the new slope times delta t. And so then I can highlight those and I can copy them all the way down. And you will see that now I have, I'm going to zoom out a little bit so that you can see the graph. But now I have my next approximation, and that took very little work. Okay, so the blue dots are my next approximation, and you'll see that when I used a smaller delta t, that I get a much better approximation of the true solution. Okay, it seems to follow the curve quite closely. So once again, it took a couple steps. First, I took my dt and I copied it down. Then I felt it was easier if I just took these first two slopes, copied them, and pasted them. Okay, and then here I'll show it to you with a blank again. So I've got my delta t. It's pasted all the way down. I filled in these two because these are different. That first row is different than all the other rows because the formula for y is different for all the other rows, because the next y is going to depend on the previous y. So if I take the second row here, I copy and paste it into the second row here, and then I paste all the way down, then that gives me my approximation for Euler's method. I'm going to do, so that's a delta t of 0.1. I'm going to do this one more time. So I'm going to take these two slopes, I'm going to copy and I'm going to paste them there. I'm going to take my delta t of 0.05, and I'm going to paste it all the way down to the end there. You can see that this is where I stored t and y. That's where I stored the true solution, if anyone's curious. But I'm going to paste it all the way down to the end there. And then I'm going to take the second row here. I'm going to copy it and paste it into the second row here. And finally, I'm going to copy and paste this all the way down. Notice that at t equals 2, that I have an approximate solution of 3.842. So that's my new approximate solution, 3.842. My previous approximation was 3.822, and then my previous approximation before that was 3.752. Now you can see the green dots. They are even more closely follow the true solution, which is the purple line. And so that using a smaller delta t gave me a better approximation.